Something terrifying is stirring beneath Yellowstone. Hidden quakes, drifting magma, and underground corridors are rewriting what we know. The volcano may already be on the move.
And a group of multi-million-dollar homes are now at the edge of a cliff after a landslide wiped away a hillside in Southern California. Now officials say they're closely monitoring the situation as some fear more rain expected this week could send them into the ocean.
Yellowstone, America's restless sanctuary, a place as ancient as time itself, shaped by fire, water, and the silent, ceaseless push of the world beneath our feet. The surface, painted with geysers and emerald pools, offers a vision of peace. Bison grazing on open meadows, forests swaying under the western sky, and rivers winding endlessly through canyons bred by epochs of uplift and erosion. Yet, Yellowstone's true essence, its beautiful, dangerous soul, thrums far below, in realms unseen. Across deep time, the park has worn many masks, shifting from fiery chaos to lush woodland, its rocks holding the memory of explosions that dwarf anything in human record. Evidence of prehistoric eruptions lies scattered in the landscape, the towering caldera rims, the layers of volcanic tuff, and lava flows now covered by pines and wildflowers. Standing at the edge of Yellowstone Lake, it's easy to forget you linger atop one of the Earth's largest volcanic systems, that the crystal water rests in a basin carved by a detonation fierce enough to darken skies around the globe. For decades, scientists have shadowed this volatile behemoth, reading its signals, listening for whispers in the earth, the hiss of steam, the rise and fall of stone, the shudder of the ground as ancient magma breathes. Geological time may move slowly, but Yellowstone is a place where the ancient and the immediate are rarely separated. Geysers that have lain quiet for long years can spring to sudden life. A hillside that slept for decades may suddenly crack open, exposing veins of mineral and steam. But recently, the story has shifted. In a remarkable scientific development, researchers revealed tens of thousands of previously undetected micro-earthquakes beneath Yellowstone's surface, 86,000 in total, identified through advanced AI analysis of seismic data. Simultaneously, ongoing research has highlighted subtle shifts in the magma body beneath the park, with evidence suggesting motion towards the northeast. These new insights have prompted scientists to ask fresh questions about the invisible workings of Yellowstone's volcanic system. Is this simply further evidence of nature's endless restlessness? Or are these findings hints of deeper processes underway? Could these invisible quakes and gradual shifts presage something more, a continued reshaping of a dynamic land? Yellowstone stands as both marvel and mystery. Its silent signals beckon us to look deeper. What secrets lie hidden beneath those famous hot springs and soaring ridgelines? How close are we to the edge of upheaval or renewal? As scientists race to decode these clues, we are left pondering, how stable, truly, is the ground beneath America's wild crown, and what new chapter may be unfolding? Chapter 1. Quiet Fury, 86,000 quakes beneath the supervolcano. It begins, always, with a tremor, a ripple so minuscule it goes unnoticed, not by creatures or machines. Yellowstone shivers, and for decades, those shudders have been counted, mapped, and analysed in search of patterns or portents. Some have long believed that nature provides warnings, a subtle thickening of the air, the sudden hush of birds before a quake, but most of the time, the Earth's labour is silent, unfelt, persistently hidden in the deep. But even the most meticulous records paled before the revelations of July 2025. When artificial intelligence was turned loose on decades of seismic data, it uncovered what human analysis had missed. A cascading array of 86,000 micro-earthquakes, tiny pulses of energy echoing from the ancient bones of Yellowstone. These are not the kind that rattle windows or fracture roads. Instead, they tiptoe quietly through the rock, each no stronger than the weight of a falling feather. but taken together, they sketch a frenetic landscape beneath the apparently calm surface. What looked from above like a placid expanse was, in truth, alive with motion. Each minute quake was a coded message, a liminal record of tension building and relaxing inside rock as hot as malice. Some were clustered tight, whispering of faults quietly shifting south-southwest of Mammoth, Wyoming. Others flickered in patterns hinting at faults and corridors where stress is focused and released. AI's analysis painted an unexpectedly intricate map, an underground constellation of stress and strain, as if the Earth itself were humming with anticipation. Deep learning algorithms, set free from human bias, found linkages previously overlooked. Clusters of tiny quakes in specific regions, subtle changes in surface temperature, and minor shifts in groundwater chemistry. The network of tiny quakes suggested a web of faults and fractures weaving through the crust like tangled nerves. And yet, to park visitors, the scenery never blinked. Tourists watched Old Faithful erupt, wolves loped through forests, rangers patrolled the backcountry. The land seemed unchanged. But under the feet of all who wandered, the ground quivered with secrets scientists had only just begun to tally. The numbers alone defied belief. 86,000 quakes, each too subtle to topple a cup or rouse a sleeper, but together an orchestra of stress and release, marking places where stone strains and slips, and where rivers of magma touch the roots of the mountains. Was Yellowstone quietly winding a spring, or slowly unwinding tension forged by millennia of uplift and erasure? Collecting and deciphering this magnitude of data required not just technological ingenuity, but a shift in how we understand geological time. Simply put, Yellowstone is always talking. It's up to us to learn the language. The discovery of so many quakes in such dense swarms challenges the assumption of volcanic dormancy. It suggests not just the slow, patient accumulation of energy, but ongoing, restless negotiation with the forces buried below. This silent labor, once unseen, now draws a new kind of scientific curiosity. If so much motion escaped human notice for so long, what else have we missed? What other warnings, coiled in darkness, whisper where only sensitive instruments, and the algorithms we train, can listen? Are there patterns that, once unraveled, could fundamentally improve our ability to anticipate changes in Yellowstone's behavior?
Chapter 2. The magma engine shifts, Yellowstone's core on the move.
Beneath every surface, a world is growing, slipping, and changing. Nowhere more so than within Yellowstone's secret heart. Once thought to be relatively fixed, new measurements reveal something more dynamic. The park's magma body, a vast region of partially molten rock that powers Yellowstone's geothermal features, is in subtle motion, recent research suggests, drifting northeastward over time. Seismologists and geologists have spent generations working to map this underground sea. They piece together the puzzle from scattered clues, the echo of shockwaves in earthquake data, the timing of geyser eruptions, the tilt of the ground measured by satellites. The magma chamber beneath Yellowstone is thought to stretch for miles, a labyrinth of molten rock and semi-molten mush, slowly stirring beneath the surface. It is the engine of Yellowstone's volcanism, the pulse behind each hot spring and fumarole. Deformation measurements, determined by precise GPS arrays and satellite radar, indicate that the surface rises and falls by small amounts every year, reflecting deep processes. Sometimes the ground lifts a few centimeters, over months or years. Sometimes it drops. These changes, typically only a few inches at most, are not direct precursors to eruption. Still, the patterns of swelling and deflation tell a story of movement. Rock is warping, and the partially molten heart below is restless. What could drive such motion? The relentless mechanics of a cooling Earth, shifts in pressure as melt accumulates or migrates, the subtle effects of water moving through fractures and faults. Volcanologists propose interwoven mechanisms, the slow ascent of less dense magma, fracturing of overlying crust, even variations in the load placed on the land by snow, ice, and precipitation. Each plays a part in the slow drama buried beneath Yellowstone.
Yet for all these changes, the visible world above is tranquil by comparison. A faint swelling, a slightly shifted geyser interval, the periodic repair of cracked roads,
These are the clues that link surface and deep. Even now, the movement of this magma body remains mostly a hidden drama deep below the forests and rivers of the park. For most, Yellowstone appears unchanged. This drifting core, a titan in slow motion, forces scientists to update their models and question old wisdom. Is this migration merely a routine reshaping of restless geology, or the prelude to something more dramatic? Is the subtle eastward shift a sign of pressure seeking release, or the ordinary breathing of an enormous volcanic system? These are open questions, ones that fuel ongoing research, not alarmist headlines. Chapter 3. Cracking ground. Faults breathing beneath the geysers. Occasionally, the Earth's hidden movements reveal themselves in surface fractures, cracks that can extend for miles across meadows or wooded slopes, sometimes accompanied by steam, new hot springs, or shifts in the landscape. Such fissures have been documented in Yellowstone over the years, though none have been catastrophic or signaled imminent eruption. Sometimes these are the result of rock layers sliding past one another as faults move, or of subsurface pressure opening pathways toward the surface. Scientists, monitoring every tremor and scan, occasionally report sudden ruptures near known seismic clusters. For instance, earthquake swarms, groups of small quakes that cluster in time and space, often coincide with subtle ground deformation or changes in hydrothermal activity. Some of these swarms, such as 33 earthquakes in just 7 days clustered south-southwest of Mammoth, Wyoming, have drawn attention. While not unprecedented, and often still within the statistical norm for Yellowstone, they warrant close observation. These splits and the rising steam that sometimes accompanies them remind observers that the landscape is alive. When deep bodies of molten rock nudge through crust, stress can accumulate. The Earth relieves this with small earthquakes or the opening of fissures. Sometimes hydrothermal features suddenly shift. Springs become muddier. Geyser intervals change, or previously dormant fumaroles start to hiss. Each such change offers scientists a fleeting glimpse into Yellowstone's mechanisms, providing data on how pressure is redistributed through faults and fractures. Each crack or swarm is, in effect, one chapter in an ongoing story, one of a powerful system, eternally balancing heat, pressure, water, and rock. Are such splits cause for immediate alarm? The consensus among scientists is no. These events are generally not signs of imminent volcanic eruption, but rather indicators of the ongoing adjustment of the subsurface to shifting pressures. Nevertheless, each is a thread adding to the rich tapestry of Yellowstone's geologic history. Chapter 4. Earthquakes in the shadows. What Yellowstone is really hiding. Yellowstone carries the title Supervolcano, yet most of its tremors are far from catastrophic. In a typical month like October, around 180 earthquakes are recorded, mostly small, shallow, and harmless. A magnitude 3.7 jolt might capture attention, but it's still well within Yellowstone's normal background activity. The park experiences thousands of minor quakes each year, many happening in short, rapid swarms. What is surprising is what new AI analysis has revealed. Tens of thousands of tiny, previously undetected earthquakes. These micro-events show that Yellowstone's crust is more active, more fractured, and more constantly shifting than traditional instruments ever showed.
Earthquakes here aren't single violent breaks. They're conversations between rising pressure, stubborn faults, moving fluids, and shifting rock. Swarms near Mammoth, Norris Geyser Basin, and within the caldera come and go. Some lasting days, others weeks, each driven by different stresses. Magma creeping northeast, faults adjusting, or water and gas slipping through cracks. Scientists map every tremor, comparing new patterns to decades of records. But predicting volcanic behavior remains incredibly difficult. Yellowstone isn't overdue. Volcanoes don't run on human schedules. So the question remains, do these rising tremor counts hint at something bigger ahead? Or are we simply hearing Yellowstone's heartbeat more clearly than ever? Chapter 5. The Yellowstone Paradox. Calm meadows, violent depths. It is the paradox at the heart of Yellowstone, a world formed by violence, reinvented every day as the calmest wild available to visitors. Geysers erupt on a schedule, springs percolate in dazzling colors, surface deformation, measured by satellites and high-precision GPS, remains largely at background levels. The park, in official scientific bulletins, seems to breathe easy. But prediction is always uncertain. Yellowstone is not overdue for eruption. No human schedule governs its convulsions. Volcanoes, those most stubborn of natural features, observe no calendar and shrug at easy forecasting. Yellowstone has seen cataclysm, its reputation as a supervolcano forged by prehistoric eruption. But researchers today agree that the system is, at present, peaceful by geological standards. Still, there are underlying fundamentals. The ground rises and falls ever so slightly. Swarms of microquakes thread through the depths. New patterns in seismicity crop up and are scrutinized. The public often hears only of major events. A swarm here, a change there, but beneath even the calmest day, the Earth's engine continues. 33 quakes in 7 days are notable, but not extraordinary for Yellowstone. Nor does a magnitude 3.7 quake spell doom. But 86,000 hidden quakes, never felt, never noticed until now, remind us how much remains unseen. How much else lies just beyond our instrument's reach. If small fissures can form without obvious warning, and thousands of quakes can slip by unnoticed, we must take care in assuming tranquility is a permanent condition. Stillness at the surface, then, hides a continual dance in the depths. Forests that seem unchanging remember fire. Rivers trace scars of old eruptions, and new springs mark the ongoing upwelling of heat and water from far below. Yellowstone stands for now on the edge of calm, but always, within, the deep machinery turns, ready to write another chapter in its ancient saga. Chapter 6. Corridors of Fire, mapping Yellowstone's underground pathways. With the extraordinary quantity of microquakes newly mapped, scientists are beginning to propose the existence of possible subterranean corridors, zones where heat, magma, and stress migrate more freely. These are not simple tunnels, but complex arrangements. Aligned faults, fractured rock, and narrow bands of intense seismicity that trace the communication lines of a living world. AI analysis, which unveiled the hidden quake swarms, also helps map these potential corridors, alignments of trembling stone that might focus stress or channel heat through the park's crust. Some clusters line up with historically active regions, others point to unexplored depths. These corridors are not mere curiosities, they are nerve endings within a vast system, reminding us that when Earth splits, it often traces old wounds. For scientists, every newly discovered structure offers hope for better understanding and perhaps, in time, more reliable risk assessment. Portable seismographs, ground-penetrating radar, and chemical sensors expand the reach of fieldwork, chasing the faint hum of tremors and temperature changes that betray these hidden passageways. When hot springs shift, when new vents appear, each can be a clue, a hint that something in a deeper corridor has changed. Are these corridors signs of future eruption, or the marks of safe release? The science is in its earliest stages. For now, these networks are vital for understanding stress redistribution, potential fluid pathways, and the evolving architecture of one of the world's most closely watched volcanoes. Chapter 7. Life on Thin Ground, Living in the Shadow of a Giant. For those who walk Yellowstone's trails, who camp beside hissing springs, who ride horses across sunlit meadows, the world seems stable, the danger abstract. Tourists marvel at the familiar, the rising mist, the distant thunder of a river falling over stone. But the true inhabitants of the park, scientists, rangers, and the generations who have known its secret faces,
carry a vigilant awareness measured in years and sometimes in lifetimes. They have lived with paradox, a land that draws life and awe from the possibility of devastation. Ancient eruptions created new valleys, new habitats, new lines of beauty. Earthquakes, sudden and sharp, have shifted rivers and opened springs. Change, whether hidden or grand, is woven into the ecosystem, the rhythm of fire, flood, and renewal. Indigenous peoples carry stories of fire and thunder, passed down through generations, painting Yellowstone as both a giver and taker of life. Modern ranchers respect sudden shifts in springs, and seasoned rangers know an ordinary day can tip suddenly to Modern ranchers respect sudden shifts in springs, and seasoned rangers know an ordinary day can tip suddenly toward the extraordinary. The latest scientific reports urge caution, not panic. Despite the thousands of hidden quakes and subtle crustal shifts, Yellowstone's caldera activity remains at background levels. No major changes have been detected in surface uplift or deformation. Still, even the calmest summary carries a quiet caveat. Systems as complex as Yellowstone's change subtly, not smoothly. What looks stable may be the lead-up to a shift. What feels like crisis could be the system venting safely, redistributing pressure to avert disaster. The unease remains. When the ground splits, when the tally of hidden earthquakes grows by the tens of thousands, when magma migrates in silence, uncertainty becomes the true law of the land. The park's beauty owes everything to this unpredictable energy, the very forces that might one day overturn its peace.
Chapter 8. The Unknown Future.
Yellowstone's next chapter begin. And so Yellowstone waits, holding its secrets as close as ever. Scientists comb the data, peer into shadows, and measure every whisper and heartbeat. Citizens watch headlines, hearts caught between fascination and fear. The Earth, meanwhile, pays us little mind. Is this mere routine? A restless park adjusting its ancient wounds? Or is it the first act in a long episode that may culminate, perhaps centuries from now, in upheaval? Are we standing on the threshold of crisis, or the slow, centuries-long healing of land forged by fire? Time will answer. For now, each crack and quiver, each potential corridor, and each silent shudder adds depth to the ongoing mystery. The numbers climb, quakes mapped, faults named, magma pinpointed, but certainty remains distant. Yellowstone's story, always, is one of beauty and danger, a wild balance between the known and the unknown. How much do we truly know of the ground beneath our feet, even with satellites and AI bringing new vision to old mysteries? What secrets lie in those corridors, in the slow drift of the magma body, in those splits and swarms that mostly escape our senses? And perhaps most fatefully, when will this land, so often peaceful, so recently split, remind us all that it was shaped by catastrophe and could, in time, be so again? Let us know what you think still slumbers beneath Yellowstone's fields, forests, and geysers. Which discovery startled you most, or which unanswered question still haunts your curiosity? Share your thoughts below and stay with us as we journey together deeper into the world's hidden stories, one trembling revelation at a time.